Claire works with Cella as a co-founder and CTO, and she has developed Cella's novel carbon injection method to optimize the efficiency of mineralization at scale. She's going to talk about that in a few minutes. Then Thor, of course, thank you so much again, CEO of Sirona Technologies, previously an engineer at Tesla, Silicon Valley for 5 years, and he applies these principles to build direct air capture machines that remove CO2 from the air. Anthony Kuria, we have a lawyer here. Thank you so much. He is the legal advisor at Mumbi Limited and Sleeping Warrior SEZ, leading a geothermal energy project in Elementaita, where these two companies have their pilot project. And last but not least, from Paris, we have Sebastien from ClimeFi, a Paris-based company managing carbon removal technologies. So I think even in terms of the carbon market ecosystems, we have a buyer, we have a project, and we also have government representing. So we'll start with 5 minutes presentation from Sirona. Thor, maybe you can take us through that.
Yep, perfect. So I wanted to start with giving you a bit of context for why direct air capture and why do we remove CO2 from the air. So I don't know about you guys, but when I ask myself what's the biggest problem in the world, my answer is climate change. I think it's probably the biggest problem of our era as a civilization. And the way you solve climate change is pretty simple. You got to go net zero, meaning we have to stop emitting more CO2 in the air than the world can remove. And the way to get to net zero, the first thing is we have to dramatically reduce emissions, right? That's what you hear most about when we talk about electrification, renewables, electric cars, etc. That's reducing emissions. But we know we won't be able to reduce emissions to zero. There's always going to be a long tail of emissions that are going to be too expensive to avoid. And that's why we also need people that remove CO2 from the air to compensate, right? So if we have this long tail of fossil fuels emissions in the air, we'll need people to remove CO2 from the air. And that's what we do. Obviously, there's many ways that you can remove CO2 from the air. Many of you know about trees that are very popular. So you can use trees. You can also use oceans. You can use soils. And you can use machines. We decided to focus on machines for a few reasons. The first one is the scalability of direct air capture machines that remove CO2 from the air, meaning they use way less land. Second is the permanency of the CO2 that we remove. So when we remove CO2 from the air and we give it to our partners, Cella, and Claire will talk about this in a moment, the CO2 is permanently removed, right? It's not going anywhere else. When you use trees, you always have kind of the risk that the trees burn or the forest dies and the CO2 is back in the air. With direct air capture and mineralization, it's permanent. And the last piece is, it's pretty straightforward to measure how much CO2 we've actually removed, which is actually super important for our customers. When we sell them carbon credits, there's a big risk that they're taking usually, which is this reputational risk, that if it turns out that the credits were bogus, they're going to be labeled as greenwashers. So it's super important for them to go towards these methods of removals where it's very clear how much has been removed so that they don't have any of this reputational risk. So that's kind of like the why direct air capture, why we're here, why we do that. And just a bit about us. So Faith just mentioned, so my background is I used to be an engineer at Tesla. I learned a lot over there, especially in terms of the engineering principles that are required to scale hardware fast. And those are extremely important in our context today, where we're going to have to remove about 10 gigatons of CO2 from the air. That's just enormous. To give you some point of reference, I think ExxonMobil, who's one of the biggest emitters in the world, doesn't emit 1 billion tons of CO2 from the air, and we need to remove 10 billion. So obviously we need to get at this problem with speed and scale, and I think that's where sort of the engineering principles that I learned are applied the best. So what do we do is, obviously we're going to be vertically integrated so that the people who are designing the machines are next to the people building it. That really allows us to iterate faster on technology to reduce costs faster. And then the second aspect is building an exceptional team, a lean team that can move much faster than larger teams. So thanks for the introduction. I think that was sort of the broad context on direct air capture. I'm looking forward to the conversation here.
Thank you so much, Thor. Maybe one more thing. You had that event this week. Maybe you want to speak a bit about
Yes.
what... Yes.
Yes, thanks for reminding me. So actually the result of our approach as a company has been sort of the culmination now was the inauguration of our pilot plants just this Tuesday at Lake Elementaita. And we're very happy to say that we're now actually the fastest DAC company in the world to deploy a pilot plant on site, and we did it here in Kenya.
Awesome, and congratulations for that. Thank you. I think as Kenya, we should also be very, very proud about that. I'll invite Claire to talk a bit about Cella. So what is the relationship between, direct air capture and what you actually do?
Yeah. Hi. Thank you for having me, and thanks for the introduction. So Thor described how we can remove CO2 from the air. It's also I'll echo how amazing it is that you deployed so quickly. It's truly a world first, and the fact that you're doing this here in Kenya is really, really special. So it's kind of not intuitive to think about carbon management and engineering CO2 out of the air. It's an invisible gas. We can't see it, but obviously we all know it's very important. So what we do at Cella is we take CO2 that's been captured either directly from the air through Sirona's technology or from an emission source, and inject it underground into rocks for storage underground. It's called geologic carbon storage. So this technology of storing CO2 underground in rocks has actually been around for decades. It's a really mature technology. It was invented and born out of the oil and gas industry, where decades ago, oil and gas producers discovered that if you pump CO2 gas underground, it actually helps recover oil production. So it's been done in the field for decades. I think 40 million tons of CO2 are injected underground every year through this process in the oil and gas industry. So it's very safe. We know a lot about how it works, and there's a lot of expertise transferable from the oil and gas industry. The problem with this approach that we're trying to solve at Cella is that we know intuitively not everywhere in the world has oil and gas resources underground. Kenya, for example, has a lot of other sources of energy, which is great, but not everywhere produces large amounts of oil and gas. So without new innovations and new deployments of these innovations, there will be large parts of the globe that are excluded from participating in carbon management technologies and excluded from reaping the benefits that this new growing industry will provide, such as jobs and economic prosperity and energy, which I think other people will touch on later. So this is simply because we don't have technologies to store carbon underground in a wide variety of rock types. It's only in the types that produce oil and gas. But at Cella, we're developing a new technology to store carbon dioxide underground in an entirely new type of rock that has been overlooked by existing geologic carbon storage technologies. And this new type of rock, called basalt or volcanic rock, is largely what makes up Kenya's geology. I'll talk about that a little later. But the benefits of our technology, other than opening up new real estate to deploy carbon management technologies, are that the CO2, when it's injected into this new type of rock, actually chemically reacts with the rock and turns to stone. So it's called mineralization. So it's the same chemical reaction that produces coral reefs and shells in the ocean. It's just simply a bond between calcium, which comes from the rock here in Kenya, and CO2, which we're putting into the rock to form calcium carbonate, so literally what shells are made out of. And we can simply speed up this natural process underground by supplying more CO2 to interact with the rock through drilling simple boreholes, really similar to what's done for water extraction and for the geothermal industry, and pumping CO2 underground. It mineralizes within a number of years for permanent storage. So yeah, I'll end there.
Thank you. Thank you so much, Claire. So zooming out and talking particularly about Kenya, because these projects are in Kenya, we know that Kenya is not a big emitter of carbon. We know there are countries that are leading in this regard. And I guess the question for some people is, why? why should we be interested as a country in this type of technology? Anthony, maybe you can speak about that. And Claire, I know you spoke a bit about the geology, but you can always add to that as well.
Okay, good morning, everybody. Very happy to be here. I think by way of background, our company, Mumbi Limited, has a geothermal concession in the Elementaita area, where we also own about 10,000 acres of land. So Cella found us as we are doing our surface exploration studies. We happened to share a geologist, and fate sort of brought an energy developer like ourselves and Cella, which was looking for a kind of geology which Claire has explained is prevalent in that area. So what has happened is really the fusion of carbon removal and geolocation with an energy developer, and that gives us a chance to really do carbon removal at industrial scale. So while Mumbi is the landlord of the two companies represented here, Cella as a storage partner and Sirona as a carbon capture company, Mumbi is looking at a captive power market from the two companies and others, because what they are doing is very energy intensive and you need green energy to do that. So it's a symbiotic relationship. Both of them add value to our property, and we are assured of a captive power market without having to try sell our energy to the national utility off-taker. So Cella is already doing an exploration well, and we are a bit invested in that because we need the data which they are generating for purposes of our own exploration wells. And then if Cella is successful, that brings us partners like Sirona and other carbon capture companies who need to be located where we are to take advantage of that storage well and also the energy we expect to generate. So it's an exciting thing, what we are doing, and it's a very, very symbiotic relationship, and it's good to see this coming alive to create one of a kind and really a first in Africa. Thanks so much.
Thank you, Anthony. I don't know if you want to reflect a bit on that, Claire.
Yeah, just to answer from a technical perspective, like why are we doing this in Kenya? Kenya's blessed with the Rift Valley, which hosts thousands of square or cubic kilometers of basaltic rock. So we estimate at Cella the potential to store 200 to 400 billion tons of CO2, which is vastly more than we'll ever need to store as a global society. And I just say that number to illustrate the potential for these technologies to scale here and the big industry that could possibly grow. It's very unique to find the right geology to store CO2 co-located with plentiful renewable energy potential. So Kenya's kind of uniquely positioned globally to be a leader in these technologies. There's been another demonstration in the world of direct air capture plus geothermal plus mineralization, and it's been successfully deployed with no adverse effects to the environment for over 12 years now, and that's in Iceland. So these technologies are proven and demonstrated to be safe, and the problem is that not everywhere in the world looks like Iceland, not everywhere has geothermal co-located with basaltic rock, but the one other place that does have that is here in Kenya. So it's kind of the next best place to grow and scale this industry. It's very similar to where it's already been demonstrated. There's hundreds of academic papers studying how these things work and how they interplay with one another. So it's really exciting that we have that foundation to build off of to catapult the growth of this industry here in Kenya.
Thank you. And maybe to also chime in on that, I would say that, Kenya is very keen to change the narrative from a victim of climate change, in a sense, to a leader. And so this is an example, one of many, of where we can take advantage as a country of our unique endowments, our unique resources, and build on that to ensure that we are contributing and leading and have a seat in the climate change conversation. So shifting a bit, so we are blessed with the Rift Valley, and with that, I think also the renewable energy potential there. We have 90% of our electricity from geothermal, and that is really, really positive. Our goal is to actually be 100% renewable and to increase our capacity. Maybe Thor, how does Project Jacaranda build on this foundation while introducing new innovations?
Yeah. So the fact that the grid is 90% renewable is super important to us, obviously. A big critic of direct air capture in the world is going to be that you're going to sort of steal the renewable energy that could have been used for something else, right? But actually here in Kenya, it's just so abundant. And so that's really great for us, right? It makes it for a really good spot to come to. If I talk a bit about our technology first and how it works, just to talk through about the kind of energy we need, it's pretty simple. So you have to imagine you've got a shipping container, right, with some fans on one side that is going to pull air through this chemical filter. And this chemical filter is going to absorb the molecules of CO2 while the rest of the air is going to go through. So this filter charges up in CO2, and at some point, to re-release the CO2, what we're going to do is we're going to inject steam in the machine to heat it up and release the CO2, all right? And so our machines actually need two things. About 20% of the energy is electricity for the fans and compressors, and about 80% is going to be the steam that we need. And so Kenya is great because on one end, as we just heard, the grid is clean, so the electricity is going to be clean. And on the other end, we also need heat. And the fact that you have geothermal systems here is actually super useful for us, right? Because if you think about like how a typical geothermal plant works, like the flash steaming technology, you're going to drill a well and you're going to have some steam and some brine coming out. So like some gases that you use to turn the turbines and make electricity. And then there's also these brines, which is like this liquid that's coming out that's at about 150 degrees C. Today, this is directly re-injected on the ground. It's just a waste heat of this process where the geothermal power plants, they want to get the steam. And so they re-inject the liquids at 150 C. So we can plug into this system to then use that heat that is currently unused, which produces a new revenue stream for these geothermal power plants. And at the same time is just exactly what we need, and which means we can also help spur the development of new geothermal power plants in the future as we will need more of this heat, right? So for us, it's really the perfect match in terms of the energy we need and the energy that's available here.
Thank you. Anthony, the renewable energy sector in Kenya is, it has a lot of potential, but we also have a couple of challenges there. How do you see direct air capture playing a role to strengthen the renewable energy sector? And also talk a bit about, how are communities benefiting from this project?
Okay, I think in terms of the challenges, especially for the geothermal sector, where we are in, the gestation periods are very long. From the moment you start your studies and do an exploration well and probably put up a power plant, you are talking of a minimum of 3 to 4 years if you are very, 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 very quick. So what we have done, especially with our partners like Sirona, we've given them an opportunity where they are also able to put up their own renewable energy source. So what they launched the other day, they have a solar power plant, a small one of about 100 kilowatts, I think, which can be scaled up. And we are looking at a model where, because of our lead times, we will give Sirona the space to do a fairly large solar plant, and whatever excess energy they have and they are not using, they'll be able to feed it into the mini grid within our industrial park. So it's still a work in progress, but we'll have an independent distributor and different energy sources, geothermal, solar, wind from other partners and not just ourselves. Now, when it comes to the local community, we've held a number of stakeholder forums. I think direct air capture is still something very new. Many people don't understand it. So it's been quite a job trying to get the local community to understand what it is and what the potential benefits are. So as a start, I think Sirona has already created a few low-level entry jobs for the local community in security and looking maybe to employ a few more people as drivers. And as this goes on, maybe technical jobs as well. So it is small. What they have started is small, but with a capacity to grow really big and probably fabricate some of the stuff locally. But for a geothermal producer like ourselves, I think direct capture is giving us an opportunity to supply energy to an industry that did not exist before. Because from what I understand, taking out a ton of CO2 and processing it for storage underground requires anything between 600 kilowatt hours to 2,000 kilowatt hours. For an energy producer, that is really the best news you can hope for. Having a captive power market in the neighborhood, and you don't have to go through an intermediary like Kenya Power and Lighting. So it's really, really a big, big opportunity, and maybe that's a model for the future for not only geothermal producers, but even other renewable energy sources like Lake Turkana wind power. So the more direct energy capture companies we have, that's new business. That's how I look at it.
Thank you. That's super interesting. Seeing that I am the only government representative in the panel, I will ask my question and I will address it myself, so bear with me. But I think just to share that, Kenya is one of the leading countries in terms of carbon markets. As of 2024, 23% of the issued volume of credits in Africa came from here. And in the last, 1 or 2 years, the country has been working very hard to, put in place regulations and policies that would take the carbon market to the next level, supporting, companies like these to benefit, from the carbon markets and attracting buyers like Sebastien here into our country. And I'm also going to invite you, Sebastien, to reflect on these regulations. But so last year we had the 2024 regulations that came into play, and I think the thing there is to, touch on the governance, elements and ensure that we have the institutional framework in the country. We have NEMA, we have the Ministry of Environment, the CCD, and what roles they actually play in terms of ensuring, this efficiency in the market. With the new dispensation, if you like, Article 6, and the potential of, issuing NDCs, corresponding adjustments, it's very important for the government to have visibility on the projects that are here. And so how, the process in which projects will achieve their letters of authorization, all those things were stipulated in that regulation. I think one of the things that's also very important that Anthony also alluded to was the community benefits as well. So the regulation also provides for mechanisms through which project developers will be able to support communities through an annual social contribution. There's also regulation or enforcement, if you like, in terms of ensuring carbon projects within Kenya comply with environmental, social standards as well. And as well, to be fair, where corresponding adjustments are issued, the government of Kenya also needs to get some type of income therein. So that's a nutshell. And actually, so that's the first regulation. There are 3 more that are under development: the carbon trading regulation and the non-market-based mechanism regulations are currently out for public consultation. So if you're able to interact with those documents, you can provide feedback. And then there will be the a registry regulation. So in order to support, sort of the carbon market infrastructure in the country. Sebastien, thank you for being part of this panel. And I'm very curious, we are also very curious to understand outside in how you view this country in light of the regulations and the projects that are here.
No, for sure. So just to, can you hear me now? Oh. Okay, so just maybe to reposition what we're doing. So at ClimeFi, we build and manage carbon removal portfolio. So we don't actually do the hard work of physically removing CO2 from the atmosphere like my colleague from Sirona and Cella, but we do work with corporate buyers all over the globe to buy carbon removals. And the buy side is such a critical piece because if you have like amazing projects like Sirona and Cella solving technical challenge, doing all of this hard work, but there's no one to pay for that actually, we don't really have a market. And so that's really where we focus is how can we bring buyers and company into this market to buy those tons of CO2 removals. And in terms of the question related to the new policy with regards to to Kenya, I think for us it's just another signal that Kenya is really, distinguish itself as one of the leading geographies for carbon removals, especially in today's climate. We've seen, historically the US with a lot of subsidies for direct air capture, which today are at risk. So nobody knows really if those, subsidies will be allocated. Another important geography has been Canada, but also if you look at Canada, they're going through a political change, so there might probably be a change in administration, and it's likely that they won't be as supportive towards like storage, for example, or direct air capture as the current administration. And I think if you look at that comparatively, it's a big opportunity for Kenya to really stand out and to, I think, take the more commitment from buyers all over the globe. We've seen buyers like Shopify with Sirona, also a few days ago the stock market in Switzerland committing to projects in Kenya. So I think those are really positive signal that international buyers are looking at the market in Kenya and seeing it as a real opportunity to commit there.
I'm going to zero in on that, Sebastien, the buyer perspective. Very interested to know, I think 2024, there was a bit of a kind of slump, I suppose, on the voluntary carbon market. Would you be able to reflect on the state of the voluntary carbon market in general? Are we seeing enough corporate entities, taking on responsibility, or, it is voluntary, if you like. And also tied to that, why would a direct air capture project in Kenya pique their interest? Like, what are some of the things that they would find interesting?
For sure. So in terms of the market, I'm going to focus specifically on the carbon removal markets because I do think it's very interesting. If you look at the market, it didn't really exist 2.5 years ago. So in 2022, the market was just starting. So there was almost no company actually removing physically CO2 from the atmosphere and no company really committing. 2023 has been the big breakthrough. So we've seen 5 million tons committed in 2023. So huge growth. That's approximately $1.5 billion value of commitments. And last year, it's been 7 million tons committed. So pretty meaningful growth. And almost $2 billion in terms of dollar value of commitment towards the space. So actually, in this specific market, carbon removals, we're seeing big growth. It's unfortunately concentrated towards major buyers. So we have approximately 100 companies globally that are committed, and it's very skewed towards the big tech companies in the US. And so we really, I think, need to bring more buyers on board. I do think also that a lot of buyers are, they don't really have an incentive or a business case yet to buy. And so I think from our perspective, we're still happy with the growth of the market over the 2.5 years. But on the same side, you've had so many projects emerge. So it feels like there is still lack of buyers in the market. And then on the last point with regards to direct air capture, I think what's fascinating with direct air capture is from a quality perspective. So really, taking CO2, storing it for thousands of years, and actually quantifying the CO2, really understanding the MRV, so the measurements, it's probably the best. I think the challenge is the cost currently, so it's much more expensive than other solutions, and also, it's the scalability. I think in the short term will take time for the pathway to get at scale. I think you have very big long-term scalability potential, but in the short term, I think we'll continue to see probably other pathways deliver volumes.
Thank you for those reflections. Maybe, because, one of the goals for the government, and I think for most African countries, is to ensure that our young people get the right skills and are able to sort of pivot into the sectors that are emerging. So back to Claire and Thor, what kinds of skills and expertise do you look out, in terms of your teams for our professional audience? And yes, start to think about your Q&As. After this, we'll have a round.
Yeah, I can start, thanks. I touched on this earlier, but Kenya, as probably everyone in this room knows, is home to the 8th largest geothermal industry in the world. And so that means tons of talent and expertise that already exists, and a lot of pipelines to continue building that talent with robust geoscience departments at the local universities. So it's really the perfect place for our technology specifically, because there are so many skills and that are basically equal, not just transferable, like identical to what's needed in the geothermal industry, like reservoir engineers, drilling engineers, geoscientists. So there's tons of opportunities for that already exist for the geothermal industry, and we're excited to build on existing pipelines that feed young people into those types of careers and expand opportunities into subsurface carbon storage.
Yeah, perfect. And on our end, and just to make it clear, so we're a company actually based out of Brussels, Belgium. That's where we come from, and we're here because of this really perfect match between Kenya and direct air capture. And so we have all the engineering and manufacturing team that is living in Brussels, and then we are having our operations here in Kenya. And so the first thing I would say is, one, we're growing our team. And we're looking for exceptional people, in all different kind of areas. Particularly where we will focus today is on the project development side. So people who can help us really with all that work that happens as you build a project and you commission these plants. And then after that, it's engineers to actually run the machines, right? So this is the operations. We always believe that you can do much more and much faster with a small team of exceptional engineers rather than a large one. And so the people we'll be looking for are people who are interested in sort of an intense, hardcore engineering culture type of environment. And then, as I mentioned, what I've learned at Tesla is that if you want to make these products better and iterate fast, not only should you be vertically integrated in the sense that you should design them and build them, but the people who are designing the machines should also be operating them, right? And so we expect to see a lot of movement and flux between the Kenya teams with engineers here running the machines and then moving to Belgium to help design the machines for the environments of Kenya, but then also engineers from Belgium moving here to Kenya to run the machines and having that constant flux so that the knowledge can really be shared and we can build one strong team, right? So in general, anybody who's excited about Kenya and direct air capture, and then particularly super strong engineers.
Awesome. Awesome. So if you want, to get into this sector or people, this is a sector to go. So I'll invite questions to, from the audience. Oh yes, I see a hand at the back. If you could please introduce yourself and probably mention to whom you're directing the question to.
Sure. Good morning.
Morning.
My name is David. I'm with Bida Sasa. We're working on electric cooking in East Africa. My question would be to you, Faith. I think in Kenya and across many African countries, we have a big issue with the NDCs, right? So the voluntary carbon market is almost, dead or zombie. So now it's all about corresponding adjustments. And as a member of also the Carbon Market Association of Kenya, unless the NDCs are changed within the next 2 weeks, I think half of us in this room will be out of business because the NDCs have room for about 5 projects in Kenya, and we'll lose about $1.5 billion of investment in Kenya alone. And I think other countries in Africa have worked on the regulatory barriers, but then we also have own goals like under-ambitious NDCs that don't allow for this new trade to actually happen to fund this space.
Okay, I can take that question unless there's another question from the audience. Thank you, David, and good to see you in person. I know we've been speaking separately before. Yes, indeed, the national determined contributions, the country's goals are very important in this new dispensation. I would argue that the VCM is dead, maybe not for so many projects, but yes, I agree with that reflection. And we're moving towards, the compliance markets now, Article 6.2 and 6.4. I do know that, the government of Kenya has been working particularly on the next phase of the NDCs, 2030 to 2035, whose deadline was the 10th of February, and not so many countries have actually managed to submit that. I know Kenya is working towards a goal of probably April. And I do hear your reflections in that sense, and I know that the government has that in mind. We do need to structure our NDCs in a way that it's very clear what our commitments are, as unconditional part of the NDC, and then what we can get from grant funding or climate finance, if you like, and as well as allow for room for carbon trading. As an office, the Office of the Special Climate on Envoy, one of the key pieces we are looking at is how our NDCs can be structured as investment tools, and how these NDCs would be read and reflected and attract investment, because this is something we do need. Going back to my previous point of Kenya being a leader in this climate narrative. So yes, I hope I have addressed your question. We can have a one-on-one conversation on that, but yeah, that is a very, very key point, I think, not only for Kenya, but for other African countries. Any other question? None, okay.
I would just maybe
go ahead.
challenge slightly the notion that the voluntary carbon market is dead. I think it depends where in the voluntary carbon market. I think some part I would probably agree, but again, if you look at the carbon removal space, growing from 0 to 12 million tons committed in 2.5 years, I think by any metrics in other markets, it would be considered like huge growth. And so I do for sure agree that we can't remain with the voluntary markets for a long time. I do think we need to move into the compliance market, and that's the only way we'll have a sustainable market, so for sure. But I do still hope and see that the voluntary carbon market can bring us there, and also setting the foundation so that the compliance market feels comfortable enough to integrate those mechanisms into compliance.
Thank you so much. I do believe we're out of time. I want to thank the panelists for, such a wonderful conversation. My first time to meet all of you, actually, and I've really enjoyed speaking with you. Thank you so much, audience, for engaging with us. Let's appreciate the panelists as we conclude.